Consider the function f of x is x plus 3 divided by x squared plus x minus 2. And the bottom can be factorized. So what we have is x plus 3 over x plus 2, x minus 1. The graph is shown here. There are examples of limits that we can see on this graph. So let's look at those. Now, if x were to be negative 2, that means that x plus 2 would be 0. We're not allowed to divide by 0. And that's why we can see when we go to x is negative 2 that there is a vertical asymptote. However, what we could do is look at what happens as x tends to negative 2. So let's look at it tending to negative 2 in this direction. So we would say that's negative 2 from below. You may see other notations for this. We can see that as we move in towards negative 2, the graph goes off the top of the page. So what we would do there is say that y tends to infinity. What if we tended to negative 2 from below, going this way? We can see here the graph goes off the bottom of the page. So if x tended to negative 2 from above, y would tend to negative infinity. We can do the same analysis at x equals 1. There are other limits out here as well. We could say that as x tends to infinity, we can see that it's asymptoting to the x-axis. So that would mean that y tends to 0. If we're being strict about that, we would say y tends to 0 from above. We could also write that as the limit as x tends to infinity of f of x is equal to 0. We can see that the same is true as x tends to negative infinity. However, these are not the limits that we're necessarily looking at in this section. In this section, we will be looking more at functions such as the one here. We factorize the bottom, we get this. And you might say, well, what's the difference? I'll just write this as 1 x plus 3 over x plus 3. You can see that we have an x plus 3 on the bottom and an x plus 3 on the top, which means that if x is not equal to negative 3, in other words, they're not both 0, we could cancel them. So we would get 1 over x minus 1, provided x is not equal to negative 3. However, if we include the possibility of it being equal to negative 3, we can't just cancel it because that would be 0 over 0, and that is undefined. Now, when x tends towards 1, the graph tends off towards infinity. So coming in this direction towards 1, we go off to positive infinity. And coming this direction, we go off to negative infinity. But when we tend towards negative 3, note we don't get an asymptote. We get a little hole in the graph. That's because that function is undefined. Or if you like, x is negative 3 is not part of the natural domain of the function. So the function just doesn't exist there. So what is the limit of this function as we go in towards negative 3? For comparison here, I have the graph of 1 over x minus 1. And you can see that it is exactly the same apart from that hole. So you may ask yourself, what exactly is the limit as x tends to -3 of that function? In other words, where is exactly that hole in the graph? We know that the x-coordinate is -3, but what's the y-coordinate of that hole? Well, since we're only tending to -3, we're not actually equal to -3, we can actually cancel the x plus 3's. We only can't cancel them when x is actually equal to -3. So this would be the limit as x tends to -3 of 1 over x minus 1. And that is going to be 1 over -3 take 1, which is -1/4.